In this video, I'll show you a multiphysics analysis of a fuse using ANSYS AIM. AIM includes a number of templates. Today I'm going to begin by selecting an electric conduction template. The template has a number of options, and I'll select electric conduction, thermal, and structural to include the effects of all three physics in my simulation. And I'll go ahead and execute the template. The template's now completed, and it's set up a series of tasks that define my simulation process. I have a task for geometry, mesh, physics, and results. To review the model, I can also activate a translucent display to help visualize the internal components of the fuse. Next, I'll continue the simulation by generating the mesh. The default mesh in AIM can be specified by setting the mesh resolution slider to define a low or a high resolution mesh. For my example, I'll simply accept the default mesh and update the mesh task to generate the mesh. Once the mesh is complete, I can review the mesh density before continuing with the problem setup. Next, I'll move to the physics task to continue with the model setup. For this simulation, I need to define material assignments. First, I'll specify a material assignment of aluminum alloy for the fuse element. I'll begin by selecting the body, and then specifying aluminum alloy from the material library. By clicking on the link for the aluminum, I can review the material properties in the library. And in a similar manner, I can define the material assignments for the fuse cover. Next, I'll apply the boundary conditions. I'll select the surfaces of the fuse terminal and apply a current of 30 amps. In a similar manner, I can define the other electric boundary conditions and the thermal and the structural boundary conditions for the fuse model. Once all the boundary conditions are defined, to review the individual boundary conditions, I can just hover over each individual boundary condition with the mouse to review their locations on the model. Next, I'll go ahead and execute the solution. I'll update the results task, and this will execute the solution and compute the multiphysics results. Once the solution is complete, I can review the results. I can review the current density, which shows the areas of high current density in the fuse element. I can also review the temperature contours, which show the effects of the resistive heating due to the electric current. And finally, I can also review the equivalent stress results generated from the thermal expansion due to the temperature field in the fuse. Thank you for watching this demonstration of ANSYS AIM.